Here's a lesson on graphing the square root function. The first thing we're going to do is we're going to graph the parent function for the square root. So the equation as a relation is y equals the square root of x. We're going to go ahead and have a t-chart here. We have our x and our y. And if you remember, when you pick values for x, we're going to evaluate it in the relation y equals the square root of x. So I'm going to start with 0. So the square root of 0 is 0. I'm going to choose 1. Square root of 1 is 1. Now if I choose 2 or 3, they don't turn out to nice numbers. They would be considered decimal places. So I'm going to go ahead and jump up to 4. When I square root 4, it's a perfect because 2 times 2 is 4. So the square root of 4 is 2. Now I'm going to jump to 9. Because if I choose 5, 6, 7, or 8, they are not nice numbers. We'd have to use our calculator. I want nice numbers out. I want integers, so I'm going to go jump up to 9. 9 is a perfect with 3. So the square root of 9, 3 times 3 is 9, so the square root of 9 is 3. I'm going to go ahead and choose one negative number. Think about negative square roots. They don't exist. If you throw that in your calculator, the square root of -1, you're going to get some kind of error message. So this doesn't exist. So I'm going to not have to worry about any of the negative integers. So now let's go ahead and graph this. So the first order pair is 0, 0. We'll call that our critical point. Then we have the point 1, 1, the point 4, 2, and the point 9, 3. So this is what the parent function of the square root function looks like. Now we have taught you already the transformations. So one of the transformations that exists is if you do a vertical shift. Remember with a vertical shift, the addition or subtraction of d is going to move it up or down. So if we have an adding of d outside the function affects the vertical axes, we're going to move that graph up d units. And it's going to affect the y coordinates. If we have a subtract d, then it's going to shift all the y values down. So we're going to subtract on the y coordinates. All right. The other transformation is when you're inside the function. So in this case, when we're inside the square root, it's going to be a plus or minus c. So if we are subtracting c, we have to think opposite. We're going to be changing the x values. And when there's a subtracting c, we do the opposite. We're going to add c. So let's go ahead and do a couple examples here, and you'll see more. This is just a review of your transformations. Now let's go ahead and put it to use. So we have the g of x equals the square root of x and then minus 3. So what we're going to do is we're going to go backwards to our parent function, which is y equals the square root of x. So I'm going to go ahead and make my t-chart again, just like in the first example. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So I'm going to graph my parent first. All right, now we have to figure out what our transformation is. If you notice that this minus 3 is outside the function, so it's going to affect the vertical axes, the y-axes. So what we're going to do is we're going to take all of our original parent function y values and subtract 3 from it. So we have 0 minus 3 is negative 3. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. Now, we are not affecting the x-axis at all. So all of these numbers repeat over here. So 0, 1, 4, and 9. And now when we graph these ordered pairs, our new function, the g of x, will be our function that we're graphing out. So let's graph it. So the first point, over 0, down 3. This is what we call our critical point. Then we go over 1, down 2, over 4, negative 1, and then over 9, up 0. Now notice each of these points is just shifted down 3 units. So if this is the point, shifted down 3 units. If this was our next point, it shifted down 3 units. If this is our point, it shifted down 3 units. This point shifted down 3 units. All right. So now we've graphed our red function, which is our g of x function. Let's just identify a few quick things here. Our parent function was the square root our transformation was down 3 units. You can also say vertical translation down 3 units. And then this is our critical point. In our parent, it's 0, 0. In our new function now, it's 0, negative 3. All right, let's do one more example. Now, we have g of x equals the square root of x plus 1. Notice the difference. This is a plus 1 inside the function, and this one it is outside the function. So, hopefully you remember now that when it's inside the function, it's going to affect the x-axis, and you have to think opposite. So you'd want to say, oh yeah, let's shift that to the right, but it's actually to the left. So what happens is all your parent function points, we're going to switch it by going subtracting 1. Now, are we doing anything with the y values? No. So that just stays as it is. All right, so let's go back quickly and graph our parent of y equals the square root of x. So you have your t-chart here. Evaluate the relation. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. All right, now, we're not doing anything with any of these y values. We're not affecting the y-axis, so they're going to just repeat over here, 0, 1, 2, and 3. But now all of these, right here, we're subtracting 1. So 0 minus 1 is negative 1. 1 minus 1 is 0. 4 minus 1 is 3. 9 minus 1 is 8. All right, let's go ahead and graph those. So the first point is negative 1, up 0. The next point is over 0, up 1. The next point, over 3, up 2. And then over 8, up 3. So let's make a note here. Here was our original critical point. Now it's shifted left 1 unit, so now our critical point is negative 1, 1. This was our next point, and now it's shifted left 1. Here was our third point, shifted left 1. Our fourth point, shifted left 1. So we should see that happen, pushing all of those points to the left 1 unit on the horizontal axis. Our parent function is our square root. The transformation that happened is it's shifting left 1 unit, and our critical point is negative 1, 0. So that's how you can graph the square root function, applying your transformations of left and right and up and down.